Drawing for Communication, Part 3, we're talking about linear perspective. Linear perspective is the more standard idea, or the more commonly known idea of basically the things that are closer are going to be larger and things that are further away will be smaller. But just like light logic, linear perspective has a systematic understanding. There are ways to effect linear perspective if you're doing a really accurate technical drawing, and these issues, these principles of linear perspective exist no matter what you're drawing, and they're there. They're kind of behind the scenes, so you don't need to set up a grid and eye level and vanishing points in order to be able to draw anything. But it's good to know that they're there and that you could if you need to, and also that you can draw something just out of your head and have it accurate in terms of linear perspective. So basically the idea behind linear perspective is that things that are closer to you will be larger and things that are further away will be smaller, and then as things are at different angles according to your line of sight, there will be rates of diminishment. So the component issues of linear perspective are a horizon line, vanishing points, and you can have bunches of those in any drawing or photograph or within your field of vision. Orthogonal lines, which are the lines that carry from the vanishing points to the object or from the object to the vanishing points. The picture plane, or your frame of reference, in this case we're looking at this photograph of the architecture, and that is the frame of reference. Everything within it is the picture plane. So obviously you can have vanishing points that exist way outside your frame of reference, but everything within the frame of reference will refer to them. The point of view is the point of view at which this would be your station point, so this is where you are in relationship to looking at this. So we're kind of looking dead center, square onto this, and we notice that there's lines that diminish one direction, there's lines that diminish and converge in another direction, so we've got a two-point perspective here. We're seeing the side face and the front face of these buildings. That is our point of view. If we walked around here and looked at the building straight on, we would have a different point of view. So point of view is, it relates to you and where you are in terms of your visual field. Orthogonal lines are the actual diagrammatic lines that we see here. They're actually the ones in red, and those are the ones that are the leading lines or the implied lines that converge at the vanishing point. Vanishing points in 1 and 2 point perspective will always be on eye level or on the horizon line, unless you're looking at something that has a slope to it, and then vanishing points can be above or below the horizon line. So with linear perspective, we have the horizon line, which is always at eye level. You have vanishing points, that's where all your orthogonal lines will converge. So all these red lines are the orthogonal lines, and they indicate the rate of diminishment of the various objects, and they all converge at eye level. The ground line is not the bottom edge of the picture plane. The ground line is the bottom edge of the object where it meets the ground closest to you. So back here, this would not be considered a ground line. The front face where it meets the ground, that's the ground line. And again, point of view, these are all three boxes are seen in 1 point perspective because they use one vanishing point. Even though we're seeing two sides here, we're not seeing enough of each side to give us two perspectives, in other words, or two vanishing points. In other words, we're still able to draw this box with vertical and horizontal lines indicating the top and the bottom and the two parallel sides. If this line is on an angle and then this one is also on an angle, that becomes 2 point perspective. So in 1 point perspective, this is the standard way we see it, where we basically see a front face and a top face. So two faces of an object and both parallel sides will lead back and converge at one point. But here we see one face, two face, and three faces, and we still have all three orthogonal lines converging at the same point on eye level. It's important to talk about eye level. There is the horizon line and there is eye level. Generally speaking, the horizon line is always going to be at eye level. So it's eye level that's the important thing, because sometimes you cannot see the horizon line. So let's define what eye level is. Eye level is really simple. It's basically the distance from the ground that you are standing on to your eyeballs. So if you are 5'6" or 5'5", somewhere around 5'1" from the ground line, from the ground plane that you're standing on, that's going to be your eye level, because that's where your eyeballs are. So you will always see the horizon line at eye level, but eye level is the main issue to understand, because if you can't see the horizon line, you still have an eye level, and so that is your point of reference for everything. Another thing about eye level is if you change your position vertically, if you sit down, if you lie down, if you stand up on a ladder, if you go up on your roof, if you go hang gliding, you have changed your eye level. So eye level always relates to you when you're looking at something. When you draw or paint or photograph anything, you are taking the picture or drawing the picture at your eye level, from your point of view. The thing is that anybody who looks at the image that you've created or captured is forced to see that image in terms of, or see what's depicted in that image at your eye level. So basically, every time you set up something to draw, to paint, to photograph, you are putting in an eye level that cannot be changed. So within this architectural rendering, eye level is about here, and obviously the ground will continue, and here's the figure. So the ground plane is here, the ground line is here for the figure, and then eye level is this distance, and we see that there's a lot of things that are above eye level that we're actually looking up at. By the way, looking at this, things that are above eye level, you can tell because you'll be seeing the underneath side of them, and things that are below eye level, you will see the tops. Things that are at eye level, depending upon where the object is situated, you won't see top or bottom if they're right, if eye level's cutting right through the center, the horizontal center. So 1 point perspective, we've got two cubes below and one cube above, and again notice we're seeing two faces, actually three faces, and three faces here, but we're still able to get the right angles on the cubes. So this is still 1 point perspective, so the horizon and eye level, the vanishing point, these are the orthogonal lines, and this is above eye level, and we're not seeing either side of this, we're only seeing the front face and then the bottom. So below eye level, things that are closer to you will be lower in the picture plane. Things that are above eye level, things that are closer will be higher in the picture plane. And that's kind of how we see things visually in just, in general, everyday understanding. So here's a drawing, an architectural drawing using 1 point perspective. Notice that everything is affected by that 1 point perspective vanishing point. You can figure out where it is by just connecting a couple lines, and so eye level's right there. If we take this implied line all the way up, and this is at a different angle, but where those two angled lines meet is the vanishing point, and everything else is falling to that vanishing point. It's diminishing and converging there, and so our eye level's right in there. This is a unfinished architectural rendering, obviously by Da Vinci, but you'll see all the orthogonal lines that he has drawn to help him get this accurately set. So we see the closer staircase is larger, than the further staircase, but everything lines up, and the vanishing point is right about in there. Actually, it's right there. So everything, this is all one-point perspective in an interior environment. It includes not just the architecture, it includes, the furniture, and it includes all the people that he's got going on in there. Two-point perspective, we will have two vanishing points, again, on the eye level or horizon line. And again, things above, we will see the underneath. Things below, we will see the tops. But notice now we don't have any right angles on any of these objects. So no right angles, that means two-point perspective. This architectural rendering is in two-point perspective. This building all relates, since it's kind of like one unit, it all relates to itself. Basically, everything that is on the right side face, all those diminishing lines will converge beyond the frame of reference, beyond the picture plane, at eye level. And we're looking down on everything except for right about here. So eye level is actually kind of out way over here somewhere. And then everything that's on the left-hand side, or the left face, is converging the other direction toward eye level. Closer to us, lower in the picture plane, further away from us, higher in the picture plane. Car, the same way. We have a little bit of orthogonal line going on that you can see, but again, the front corner is here. We have the front face where the grille is. We have the side face where the two tires and the door are. And despite the fact that we don't really have any straight lines in this, the rendering of this Camaro, the corner, the closest corner is right here. And then we have the top, and we have the side face, we have the front face, and you can draw boxes around this and figure out that the whole thing is below eye level. Eye level is probably right here, and this vanishing point would be within the frame of reference. Three-point perspective means that you generally will not be at eye level, or if you are, you're looking up or you're looking down. Usually you're above things. So for three-point perspective, you can get on top of a ladder and look down at something and you'll get the idea. With three-point perspective, you do have eye level, you do have vanishing points, but then you have converging lines. With two-point perspective, all of your vertical lines will be vertical, so they won't converge. In three-point perspective, your vertical lines will converge to a third vanishing point that will be above or below eye level. So you can see that these three lines are now no longer parallel, and neither are these. This is a sloped item like a pyramid, and this would be a cube that we're seeing a lot of the top of. And so the bottom face that we can't see is diminished in scale from this, although in reality it would be the same size. This Escher obviously uses three-point perspective. We have this face, we have this face, lots of angles there. Eye level is up here outside of the picture plane, but notice the third vanishing point where this line is going to converge, and this one, and this one, and this one, and that's way out of the picture plane. It's another architectural drawing. Again, because of the slope, we have the sense that we're actually maybe sitting on the sidewalk or sitting on the ground, lying down on the ground, not even standing up. But the three-point perspective will give us the ability to look up at something and make it appear monumental, or to look down on something and make it look minuscule. So it's kind of a worm's eye view or a bird's eye view.